Hey, it's Mr. Lum, and we're going to continue on with some Science 9 stuff, chemistry, and talking about physical changes and chemical changes. So the first one we're going to talk about is physical change, and hopefully you have a copy of the guided notes. So it says physical change, change that affects the form, or in other words, the phase, but doesn't change the chemical composition. So I have an example here, and I picked this example because I think we're quite familiar with it. Here's H2O, and this S right here signifies that it's a solid, or in other words, this is ice. So there's some ice right there. And it changes into H2O, but this L signifies that it's a liquid. Now, we're all familiar of how to change ice into liquid or ice into water, and you heat it up. You take ice and you add some heat to it, and that causes the particles to move around and spread themselves out and all that kind of stuff. So this is a physical change because even though we change the way it looks and the way that it is contained and all that kind of stuff, if you look at here, the particles are physically the exact same. They started off looking like this, and they still look like this. They did not change throughout, okay? They were just together, but it was still one oxygen with a hydrogen and another hydrogen that were like that, okay? And they are still exactly the same, one oxygen and two hydrogens. So this is just a physical change. Now, what about a chemical change? So a chemical change is when a compound changes the way the atoms are arranged. So here I have some Na, O, and H. Na stands for sodium, O stands for oxygen, H is for hydrogen. And here's the chemical right here, Na and OH. And we're going to react it and combine it with HCl, HCl. And what happens is they change like this. And now these are supposed to be together, but now we have Na is with Cl right here. We have NaCl, and now we have these two H's and the O right there, and that's H2O. So the sodium, the Na, was with the O and the H, and now the sodium is with the Cl. And so this is considered a chemical change because it changed the way the atoms were arranged. So what I want you to do is in your guided notes, you have several questions and a graph and all that kind of stuff that I want you to work on. You are going to be using your textbooks to see if you can try and find those 5 definitions in your textbooks, and you're going to be working on that for a little while. You're going to make that graph for question number 5, which says mercury is a metal with a melting point of -39 and a boiling point of 357. Please graph this below. We saw a graph like that in our last class where it went from solid, liquid to gas. So we're going to be making one like that, but it's going to have a different melting point and different boiling point. And after you finish that, we're going to come back to this video right here and finish up some of our guided notes. So right now, hopefully the video is on pause, and then we can come back to the guided notes. Okay, so hopefully the video is now unpaused, and now we are ready to continue on with some of these guided notes. So the next one is endothermic reactions and exothermic reactions. So an endothermic reaction is a reaction that absorbs energy. An exothermic reaction is a reaction that releases energy. And Endothermic reactions are a little bit tricky to figure out if something's absorbing energy. Exothermic reactions are a little bit easier to see sometimes. Now, when I say absorbs energy or releases energy, typically that's in the form of heat. Is it releasing heat or is it absorbing heat? If it's absorbing heat, it's endothermic. If it's releasing heat, it's exothermic. Exo as in exiting, heat exiting, or thermic being like thermometer. So exothermic is heat is exiting or releasing. Endo or entering, heat is entering the reaction. Okay, so let's take a look at a few examples and see if we can figure out, is that endothermic or is that exothermic? Okay, so the first one is an egg is cooked in a pan. Okay, so is the egg endothermic or is it exothermic? So what we can see is that, is it a chemical reaction? And it is, like the egg is changing colors, it's changing the way that it feels and the way that it looks and everything like that. So the egg that is being cooked is a chemical reaction. Now, is that egg an endothermic or exothermic? Okay, so in order to figure this out, I want you to kind of put yourself in the egg's perspective. So is energy or heat entering the egg or is it leaving the egg? Well, hopefully you kind of understand that energy or heat is going into the egg. Energy is being absorbed into the egg from your cooking surface. So since it's entering or absorbing, the egg is absorbing energy to have that chemical reaction, it's endothermic. Now, what about ice melting? Okay, so how does ice melt? Let's think about that. So ice melts by, well, you have to add heat to it, right? So you have to take heat or energy and it has to go into the ice, and therefore it then turns into water. So ice has to absorb energy in order to turn into water, and that makes it endothermic. Okay. Now, wood burning. Okay, so here's where it gets a little bit tricky sometimes, because you're probably thinking of like wood burning or paper burning. How do you do that? Well, if you want to burn some wood, you got to put a lighter to it, right? Or you got to add some heat to it to start it burning. Okay, and that's true. You do have to add some heat to it, but if you say like you add a little bit of heat, but it's going to be giving off a lot more heat energy than it absorbed. So even though it absorbed a little bit of heat energy, it's going to be releasing more heat energy than it absorbed. And since it is releasing energy more so than it absorbed, it's exothermic. So even though it absorbs a little bit, it releases more than it absorbed, therefore exothermic. Okay, a chemical cold pack. This one should be hopefully easy. So if you don't know what a chemical cold pack is, like maybe if you have an ankle sprain or something like that, a coach or a trainer or something like that will take a little bag out of there and squeeze this bag, and then chemicals inside the bag will pop and mix, and then the package will get really, really, really cold. Now, the reason why it feels cold to us when we touch a chemical cold pack is because it's taking all of that heat energy away from our ankle and it's going into that cold pack. So it's taking energy away, and that energy is being absorbed in that chemical cold pack, and therefore this thing is endothermic. cold, when something feels cold, it feels cold because it's absorbing our energy. Okay, so it's absorbing energy, therefore it's endothermic.